All right, so if we look at this first one, we need to isolate. We need to isolate this. We need to leave it all by itself. Absolute value of 4x minus 8. So what's the first thing I need to do? Like, what's the first move here? The third isn't going anywhere yet. Add 5 to both sides. So if I add 5 to this side, this goes away. Add 5 to this, it becomes 12, right? I need to get rid of this 1/3 in the front. Remember how to get rid of fractions. You just multiply by the denominator. So I multiply this side by 3, which will cancel this out. Multiply this side by 3. On the test, there was a similar problem to this, I think, with parentheses. And this stage, like, some of you remembered to do it, and you even wrote it on both sides, but you never actually multiplied it over here. And that throws off your problem. So 3 times 12 is 36. These two cancel each other. So we're left with absolute value of 4x minus 8 equals 36. And you see why we would have got a completely different answer had we multiplied by 3 first, right? Because 3 times 7 would be 21. And then if I had added 5 to 21, I would have had 27 here. I would have had the wrong number. So the order does matter. You always want to use addition and subtraction first when you're solving. Get rid of those. And then multiplication and division. So from this point, we're good. We got absolute value equals some number. So that means there's 2 answers. So here you split it. And when we split it, it comes out of the absolute value bars. Because we're going to account for the absolute value right now. I'm going to say 4x minus 8 equals 36. And then 4x minus 8 equals negative 36. Because if either of those things had happened, you would have ended up with this. Because if I put negative 36 in here, you get positive 36. If I put positive 36 in there, you get positive 36. So that's why we can get rid of the absolute value bars here, because we're solving for both things. So we don't need the absolute value anymore. So if we add 8, now I'm going to show you guys another way to do this. If I add 8 to this side, I get 44. Divide by 4, I get x equals 11, right? If I add 8 over here, what do I get? If I add 8 to negative 36, negative 28, right? Adding a number to a negative is almost like subtraction until you get to 0, right? Like, it's like I'm adding 8 here, and it's almost like I'm subtracting 8 from 36, but I'm not, because think about like the number line. You're just like moving up the number line. Negative 36 is way down here. If I move up 8 spaces, it brings me to negative 28. Use a calculator for those if you have trouble with those negative integers. Negative 28 divided by 4 is x equals negative 7. So if we try either of those out, I'm just going to walk through it here. If I put 11 up here, 44 minus 8 would be 36, right? 1/3 of 36 is 12. 12 minus 5 is 7. So that one checks. Negative 7. Negative 7 times 4 is negative 28. Minus 8 is negative 36. Absolute value of negative 36 is positive 36. And then you're right back to where 1/3 of 36 is 12. 12 minus 5 is 7. So they both check. Now, notice I did not change anything in here. See how it's 4x minus 8 still for both? The only thing I put a negative on is I made this a negative and a positive. I solved for both situations. Now, if you watch a video on this, or someone else tries to show you how to do it that does it differently, there is a different way to do it. It's still, when you reach this point, you'd still split, but instead of making the 36 negative, another way you could do it is I can take 4x minus 8 and set it equal to 36, and then I would take negative 4x minus 8 and set it equal to 36. It's no different. it's just starting with the negative on this side. I know that the only teacher I know for sure that teaches it this way is Mr. Gwynn. So if any of his students help you with absolute value solving, they do it this way. But notice what I didn't do is I didn't change this to a negative 36 here, because if you combine kind of both of these ideas, you would be undoing it. So you can go with one way or the other. Either you make what's in here negative like this, and then don't change the sign on this outside part. Or I personally think it's simpler just to make this number negative and then solve it. But they'll both bring you to the same answer. Like here, I would say 4x equals 44, x equals 11. And then if I distribute this negative, I get minus 4x plus 8 equals 36. Subtract 8, and you get minus 4x equals 28. Divide by negative 4, you get x equals negative 7. So you can get the same answer either way. You just don't want to do both things. Like if you do this and make it negative, it would immediately be undone and you just get the same answer twice. So I personally like this way better, and that's how I'll always solve these if I show them, where I do the number and then just make that number negative, but you don't change anything from inside. And that's kind of easier, because here, when you distribute that negative, you got to remember to distribute it to like both terms, or it throws off your answer, and it just kind of leaves you open to more mistakes, I think. But either way will work. Some people will show it this way, which is perfectly fine if you want to do it that way. I'm not going to say you have to do it this way with the negative number. I just believe this is an easier method. But at the end of the day, it's up to you which one you like better. I'm not going to like force you, like pigeonhole you one way or the other. All right, so if we look at this one, remember our first step is always isolate the absolute value. So what do we need to do here to isolate this absolute value part? We just need this part by itself, absolute value of 3x minus 1. It's times 2 here, so how do we undo a times 2? Divide by 2. Just think about that opposite action, right? So if we divide both sides by 2, we end up with the absolute value of 3x minus 1 equals negative 7. Now before we do anything else, you'll find yourself with these problems, you'll be like, oh, let me just split it, change it to a positive 7. But what's the problem with this? What does absolute value always equal? The outcome of an absolute value always has to be positive. So when you run into something like this, when the absolute value is isolated and it equals a negative number, it has no solution. Because there is no number I can put in here for x that would possibly give me a negative number after an absolute value, right? And it's easy to kind of get into the mode where you just, let me just split it quick and solve for positive 7 and negative 7. But there is no real solution, and I'll show you how you catch that. Let's say we forgot, right? And we just got to this point and we said, well, 3x minus 1 then equals negative 7, and 3x minus 1 equals positive 7, right? And if we find our two solutions, this is how you catch your mistake if you miss it over here. We get x equals negative 2, right? And then here, if I add 1, I get 3x equals 8, x equals 8 over 3. Now, if I try either of these back up here, like if I put negative 2 in here, that would give me negative 6. Negative 6 minus 1 is, like if we sub this in, and we want to see if it equals negative 14. 3 times negative 2 is negative 6, and then minus 1, right? So that would equal 2 times the absolute value of negative 7. Absolute value of negative 7 is 7. So we get 2 times 7 equals 14. But is that our is that what we were trying to get to? we had to show that it equaled negative 14. It equals positive 14. So